Today we're going to analyze graphs of quadratic functions, but before we proceed with that, we're going to do a quick warm-up to review completing the square. In order to complete the square, remember, you need to have your constant by itself, which is already done for us. So we take our x squared plus 4x, leave our space, our constant's over there, we have our other space. So we take half of our coefficient of x and square it, add that to both sides. Now we're going to factor. It's a perfect square trinomial on the left-hand side. So we've got x plus 2 quantity squared equals 16. Take the square root of both sides. So x plus 2 equals plus or minus 4. If we simplify this, we get x equals 2 and negative 6. Do a quick check. Those both work. One more warm-up. In this one, remember we have a coefficient in front of x squared, so we have to get rid of that first. Divide everything by that coefficient, which will give us some fractions to deal with. I'm also going to move my constant over to the other side as I rewrite this as x squared minus 3/2 x. Leave my space. My 1/2 is going to go over to the other side of the equal sign as negative 1/2. Another space. Now we're going to take half of 3/2 and square it. So half of 3/2 is 3/4 quantity squared, which gives me 9/16 to add to both sides. Once I simplify that, my half was 3/4, so that's the amount that goes inside my parentheses, quantity squared. If I simplify the left or the right-hand side, I have to combine like terms, meaning I need to turn my negative 1/2 into a denominator of 16, which is negative 8/16. So when I simplify over here, I'm going to have 1/16 square root both sides. On this side, I'm going to have x minus 3/4 equals the square root of 1/16, which is plus or minus 1/4. We have a common denominator already, so when we simplify, we get x equals 1 and 1/2. All right, so that was a review of our completing the square topic that we learned previously. Moving on, the graph of a quadratic function is a parabola. We can write the equation of our quadratic in what's called vertex form. So vertex form is the form y equals a, so that same a value that told us what direction our parabola opened up in, times the quantity x minus h. H is going to be the x coordinate of our vertex, quantity squared, plus k, which is our constant, and the y coordinate of our vertex. Our axis of symmetry is x equals h. Again, that's the x coordinate of the vertex. If a is greater than 0, it opens upward. If a is less than 0, it opens downward. The narrower the graph of y equals x squared happens if the absolute value of a is greater than 1. The wider the graph of y equals x squared happens if the absolute value of a is less than 1. Pretty much what you need to remember is fraction is fatter. Fraction is fatter. So again, if the absolute value of a is less than 1, meaning if you have a fraction for your a value, your graph is going to be fatter. Here, y equals x squared is the parent graph of the family of quadratic functions. As the values of h and k change, again, the coordinates for our vertex point change. The equation y equals a, x minus h quantity squared plus k is the graph of y equals x squared translated based on that change of your coordinates for your vertex. If we look at this, our graph is going to translate horizontally if absolute value of h left is if h is negative, or absolute value of h right if h is positive. Next, if we look at our graph, it's going to translate vertically k units up if k is positive, k units down if k is negative. That'll make sense once we graph a few of these. So we're going to analyze this quadratic equation from vertex form. So if we look at it, the coordinates of our vertex are always our h and our k. So here's our h, here's our k. Remember, for the h value, you pull out the opposite of what's inside your parentheses. So our vertex is going to be at 3, 2. Our axis of symmetry is always x equals that h value, or the x coordinate of our vertex. So x equals 3 is our axis of symmetry equation. In order to graph this, we're going to make a quick t-table. Vertex in the middle, I'm just going to pick 2 additional points. Our a value is a 1 right there, so we know our graph opens up. And now we can graph this. We know it opens up, we've got 3 points. Okay, and that's what our graph should look like. If we look at the next example, very similar again. This time, our vertex is going to be at -2. Remember, you take the opposite of what's inside the parentheses, and then your k value is going to be -1. Axis of symmetry, x equals -2. Our a value is -6, so opens down. When we make our quick t-table, plug in 2 more values. And if I look at my a value, it is not a fraction. It is actually a larger integer. So we know that our graph is going to be narrower. So when I draw my graph, I can expect it to be a little thinner than what our parent graph usually is. All right, so we plot our points, vertex, and you can see when you trace it out, it is going to be a little narrower. So there's our graph. Now, we're going to write the quadratic function in vertex form. So this again, y equals a times the quantity x minus h squared plus k is vertex form. In order to do that, we do not have a perfect square. So to have this happen, we have to complete the square. And that's why we practice completing the square prior to this. Now we're only completing the square on one side of the equal sign. So it's going to change what we do just a little bit. In order to do that, I'm going to rewrite my equation, my quadratic, and separate my first 2 terms in parentheses from my constant. Now, notice I'm not moving anything to the other side of the equal sign. Why is that? Because the only variable or number I want on the left-hand side of the equal sign is going to be the y. So everything else is going to stay where it is. We're just going to write it in a different form. In order to do that, I have to finish completing the square. Now, again, we're going to take half of our b value and square it. So half of 2 is 1. 1 squared means I add 1 inside my parentheses. Now, because I'm only on one side of the equal sign, if I add 1 to this side, I also have to take that amount away. That means I'm also going to be adding a -1 to the same side of the equal sign. This is what we call balancing the equation. Now I can write my equation in vertex form. We already have the y equals. I'm going to factor my x squared plus 2x plus 1 into a quantity squared, so x plus 1 quantity squared, and I just simplify my constant, which is my k value, to plus 3. I now know that my a value is a 1 right here. You don't have to write it there. It can be an imaginary one. My h value is -1, and my k value is 3. Let's try another one. We're going to write this quadratic equation in vertex form. Then we are going to graph it and look at what the graph looks like. In order to put it in vertex form, remember, we're not moving anything from one side of the equal sign to the other. We're just separating stuff out so we can complete the square. Put your first two terms. Actually, before I even do that, I notice that I have a coefficient in front of x squared. I have to get rid of that. Now this is a little bit different as well. When we divide the -2 out, it goes in front of the parentheses, but the only two terms inside the parentheses are the x squared and the x term. So I have x squared minus 10x inside my parentheses. I'm not going to divide -35 by -2, and I'll show you why in just a minute. Let's continue completing the square. So as we do that, we take half of -10, which is -5, and square it. So I'm adding 25 inside my parentheses. Now, I need to balance my equation. So instead of adding 25, you would think I would add -25. Well, I'm not just going to add -25. I'm going to add -25 times -2. Why am I doing that? Because this -2 right here is actually distributed to that positive 25. So we actually have to get rid of that entire amount. When I do that, remember, instead of adding 25 and subtracting 25, I'm actually adding in a -50, so I have to subtract my -50 as well. We're going to continue simplifying, so y equals our a value of -2, x minus 5 quantity squared is what I get when I factor. And then over here when I simplify, -35 plus 50 is a positive 15 for my k value. So my vertex is at 5, 15. Axis of symmetry is x equals 5. Opens down because a equals -2. And if I want to graph, I can do a quick t-table. So I have my vertex at 5, 15. Sketch a quick graph.